Okay, as promised, I just wanted to run through this test question from last week, okay? So here we have gx, and we've been given some information, point of inflection at x is equal to t, and a max and a min at p and q. So let's start to develop this so that we can get as far as the maximum and the minimum. So obviously we'd go for the g dash x, and we'd clearly get 3ax squared plus 2bx plus c, okay, for the first diff. So I'm going to go g dash of p first of all, and we'd have 3ap squared plus 2bp plus c, and this must equal to 0 because this of course is the max. Then they told me that g dash of q is also a turning point, so go 3aq squared plus 2bq plus c is equal to 0, okay, again. And then by observation, then we might want to say to ourselves that we're after p plus q from this group. So we definitely don't want c. So I just was looking at maybe the concept of trying to solve these simultaneously. So that would, I'm trying to change the sign on the bottom row so that I can minus out the bottom row. So I'm going to minus here, minus here, minus here. Okay. And then that kind of gave me 3a times p squared minus q squared plus 2b times p minus q. And then the c's would cancel. And then after I had done that, and not before, after I had done that, I was able to see that I have p squared minus a q squared, which of course is the difference of two squares. And that kind of led me to decide to factorize this because I could see the p minus q there. So I went 3a times p plus q by the p minus q plus the 2b times p minus q is equal to 0. And then I could see that I have a common factor running across there, which is p minus q. So I decided to cancel that out. It's basically dividing by p minus q. Now, I'm left with 3a times p plus q plus 2b. And it's kind of getting closer to what I want because I definitely want to establish what p plus q is. So I bring over the 2p. So I got 3a times p plus q is equal to minus 2b. Okay. And then I get the p plus q must be minus 2b over 3a. Now I just decided to stop at that and look at the point of inflection because I knew there was nothing else I could do there, and I'd clearly had the p plus q established now. Then I went on to the point of inflection and I said, look, I'm going to differentiate this again for the point of inflection, and I did give you 2 marks for doing the differentials. So we got 6ax plus 2b, and that's going to equal to 0 at t. So 6at plus 2b is equal to 0. So let's see what we get out of that. So we're looking for t for this side. So we get 6at is equal to minus 2b, or t is going to be equal to minus 2b over 6a, right? Which of course is minus b over 6a, sorry, over 3a. Now, that's clearly what t is equal to. And 2t is what you'll need, which is going to be minus 2b over 3a. And now we clearly see that p plus q, that implies p plus q is clearly equal to 2t. So we've done our question 1, okay? Our question 2, you made a good fist of it, everybody. So I have it here is 3a times the x squared plus the 2bx plus the c is to be analysed. And what they've said is basically that P and P is equal to Q. That's basically what they've said. P is equal to Q, right? Now, if P is equal to Q, it's actually also equal to T, but let's not worry about that too much, okay? Right, so basically the solution to this, right, what happens with this? Okay, well, basically B squared minus 4AC has got to equal to 0. So we put all of that in here and we get B squared minus 4AC. We tidy that up, we get 4B squared minus 12AC. 4b squared is equal to the 12ac, b squared is equal to that, and we need the a on its own, so we get b squared divided by 3c. Okay, now just to give you a quick look at how to do part 3, I'm not going to fully finish it out, okay? Basically now, if you know that this is only one solution to it, right, then you know that the b squared minus 4ac bit is 0. So I put this into the formula, the minus b formula. So the minus b formula is normally minus b plus or minus the square root of b squared minus 4ac over twice a. Now, you'll have to read the question to understand where I'm getting at this as well now, boys. But what it has said is if there's only one solution, right? So if there's only one solution, what we see here is b squared minus 4ac is clearly equal to 0. So this is 0. So now I'm down as far as minus, but I have to use 3a instead of in for the a. So this will be subbed in as 3a, and the b in this case is minus 2b. Okay, so I'm subbing that in next. So I go minus 2b, right, it's gone in here, over 3a twice a, which is 3a, okay, which of course then gives me minus b over 3a. All right. Now, the thing is, this question said in terms of C, B, C, and D, so we can't use the A. So instead of having the A, we put in this for A. So we get, so that in for the A, so we get minus B over the 3A, which is B squared over 3C. So we see the little 3's cancelling. Let's get minus BC over b squared, which gives me minus c over b. So my x coordinate is minus c over b. Now you sub this back to get in the y coordinate. It's a little tricky, but it is possible. You sub that back into the fx. Okay, I'm not going to do it for you because it's a bit tricky this time. But any of you who want to do it, feel free to do it. Okay, so the main thing about this video was to have a look at how I established this, which I do agree was very, very tricky. So that's why I reduced the marks on it there for you and shortened it. Okay.